In the mid-1990s, rendering 3D graphics on a personal computer relied almost entirely on software. Your CPU had to do all the math, which meant inners were stuck staring at slow, jagged, pixelated polygons. Then came a company called 3DFX. They introduced the Voodoo card, a dedicated piece of hardware that bypassed the CPU's limitations to accelerate 3D rendering. Overnight, 3DFX captured nearly the entire market, becoming the absolute authority in Silicon Valley hardware. This system diagram illustrates how they protected that lead. 3DFX created Glide, a proprietary software language that let games talk directly to the Voodoo card. Because Glide ran so smoothly, developers optimized their games specifically for it. If you were a competing hardware maker, you were locked inside a walled garden where your chips couldn't read the code. The only way to break a software monopoly is to outpace the hardware it runs on. A tiny startup led by Jensen Huang called Nvidia entered to market with a strategy that the industry considered a total design suicide mission. Take a look at this timeline chart. Traditionally, designing and manufacturing a new semiconductor architecture took years. Nvidia committed to a 6-month product cycle. They decided to release a completely new generation of hardware twice a year. 3DFX was sitting comfortably on massive profit margins and an industry-standard API. They assumed their market share would protect them, failing to recognize that a rival operating at double the speed of the rest of the industry would eventually close the gap. Nvidia started by dismantling the software wall. Instead of building their own proprietary language, they threw their full support behind open industry standards like Microsoft's DirectX and OpenGL. Now, developers could write a game once and it would run on any hardware. Faster, driving pace. With the software playing field leveled, Nvidia's 6-month cycle kicked in. In rapid succession, they launched the Riva 128, the TNT, and the TNT2. They iterated, learned, and manufactured at a breakneck pace. Meanwhile, 3DFX stumbled. Struggling with internal engineering delays, they pushed the release of their highly anticipated Voodoo 3 back by months, missing critical holiday sales windows while Nvidia flooded the market with fresh silicon. This data flow model highlights the major computing problem of the late 90s. Even with 3D accelerators, the computer's CPU still had to calculate exactly where every polygon was and how the light hit it. This process, called transform and lighting, created a massive bottleneck. The CPU simply couldn't feed data to the graphics card fast enough. In 1999, Nvidia solved it. They released the GeForce 256. Watch how the model changes here. Nvidia offloaded the transform and lighting math from the CPU entirely, placing it directly onto their own hardware. They coined a new term for this specific architecture, the Graphics Processing Unit, or GPU. This technical comparison shows the difference in engineering philosophies. On the left, Nvidia's GeForce 256 uses a unified, efficient design. On the right is 3DFX's response, the Voodoo 5. Instead of solving the transform and lighting bottleneck, 3DFX tried brute force, slapping multiple older chips onto a single, massive, power-hungry board. Attempting to scale up an obsolete architecture requires more electricity, more silicon, and yields diminishing returns. Designing a completely new logic flow clears the data traffic jam at the source. As the engineering gap closed, the panic inside the 3DFX boardroom set in. Nvidia was now producing faster, smarter hardware, forcing 3DFX leadership to look for ways to protect their revenue. Up to this point, 3DFX made money by designing chips and licensing them to third-party board manufacturers who actually built and sold the physical cards. In a bid to capture 100% of the profit margin, 3DFX announced they were cutting off those partners. They purchased a manufacturer named STB Systems to bring all production in-house. Suddenly, a company that specialized in chip design was saddled with the massive expense of running a physical factory. Watch this supply chain network graph to see the immediate fallout. 3DFX effectively fired their best distributors, companies like Asus and MSI. Those manufacturers didn't stop building graphics cards. They instantly walked away and signed exclusive supply contracts with Nvidia. By locking down their hardware, 3DFX isolated themselves, absorbing massive production costs right as their main rival captured the entire collaborative market. 24 months after Nvidia introduced the 6-month cycle, the war was over. By December 2000, 3DFX had run out of cash and filed for bankruptcy. Nvidia stepped in to act as the liquidator. For approximately $120 million, they bought 3DFX's patents, absorbed their remaining engineering talent, and acquired the brand name of the company that once owned the industry. The collapse of 3DFX proved dominance in the hardware industry is not guaranteed by past products. It is dictated entirely by your rate of adaptation. That exact methodology, championing open ecosystems, solving structural data bottlenecks, and iterating architectures at punishing speeds, didn't stop in the 1990s. Nvidia carried it forward for the next 2 decades. The aggressive strategy that Jensen Huang used to dismantle a graphics rival 30 years ago built the operational foundation that allows Nvidia to supply the vast majority of the world's artificial intelligence processing today.